EMY?
Yeah, I was using it for school today. Can you find me it's right here on the table. Could you grab me a pencil while you're over there? What happened to all the pencils? There were like 3 on the desk here. Oh, God.
Where's the timer?
Right there.
Okay. Have a good shower.
Ah! Anya's on! Yay! Hi!
Hi!
Hello? Can you guys hear me? Okay, hi.
Hi!
This is so weird. It was like trying to tell me like I had to be 18 years old and stuff when I couldn't join for a second. It's been really weird. Well, I'm on now. So I feel like my brain's fried from trying to read all of it and do the problems and stuff. I feel like I'm just so fried.
Yeah. So I worked on it. I didn't have the chance. I learn best when someone's there to like show me how to do it. So I've been going to the tutor the last couple times, and that's helped a lot. But Mondays and Wednesdays are my busiest days, and I don't have time to go to the tutor on Mondays and Wednesdays. So I won't be as much help tonight as I would be tomorrow, because I'm going to go to the tutor tomorrow.
Okay.
And get help. Anyway, so just FYI, I'll be confused today, but I'll understand tomorrow. So
It's totally fine. This stuff is, kind of hard.
yeah, it is.
Time consuming. It took me a while to like read and do the problems and stuff, so it's time consuming.
It's really time consuming.
Okay, so
Emily, how's it coming?
is Emily here?
Well, that's strange. Yeah, do you want to just come over here and we'll share? Pull up to that side. Okay, Emily's coming.
Okay. Let me get the preparation assignment. So Kara, did you understand most of it?
Yeah, I was just telling Erin I did fine on all the problems as long as I could like refer to the textbook.
Yeah. The only thing was like for me, what does it mean unusual? I mean, not unusual.
Oh, so that one was if it's more than 2
2.28.
Yeah, so if it's more than 2 standard deviations away from the mean, then it's unusual.
Okay, I got it right. I was just making sure. I was like, okay.
Yeah, so as long as if it's less than 2 standard deviations away from the mean, then it's not unusual. But if it's more than 2, then it's unusual.
Okay. Yeah.
So, for example, for number 1, you would subtract the mean and then divide by the standard deviation on each of those numbers to find out the z-score.
Yeah, I did it all, but I was just making sure that I was like, I know how to do it. I knew how to do the problems, but to decide if it was usual or unusual, I was like, okay, I don't really
Yeah, it's like just the 2 is the magic number. So as long as like up to 2 is not unusual, and over 2 is unusual.
Well, the D, it was, did you get 2.176?
Mm-hmm.
Yeah, and so that was unusual.
Yes.
So it's because it's above 2, right?
2. Right. Yeah, and A was only 2.08, and that was still unusual because it's just a teeny bit above 2.
Yeah, it was negative 2 point.
Yeah, negative 2.
Yeah, that's the average.
And and it doesn't matter if it's negative or positive. If it's larger than 2, then it's unusual.
Okay.
Can either of you explain the 68, 95, 97.7 rule?
Oh, yeah.
Wasn't that the first division, second?
It's quite simple, isn't so the 68% is within 1 standard deviation, in the graph when you see it.
Mm-hmm.
So it's just like percentile, like it's like the bell shape, and so the 1 standard deviation is 60%, and the next one's 95, next one's 99.7. That lie in that category.
Okay. Perfect. That makes sense.
Yeah. Okay.
So do you guys want to move on to part 2?
Yeah, let's get part 2. Let's see. I thought, oh my gosh, I had problem with. I had problem with E.
With D?
E. On 7.
Oh yeah, I didn't even get to 7 yet. I did 6.
Yeah, no, we can all do it together. I was just waiting. So, okay. So, did you get 6, Emily or Erin?
No, so I did the preparation part, but like I said, I get really confused. Like math is just me, there's math, like it's great. Anyway, so
Don't worry, I just listened forever.
So that's why I said, like, once I go to the tutor, it helps a lot because then they explain it and we understand. But I just got confused. So I'm really, really sorry.
No, don't be sorry. Math is my weakness too. So, and did Emily get it?
No, I don't have it either.
Okay, so let's read it together. Yeah. Do you guys want to read it?
Yeah. Okay. The mean score of all GRE scores is 150.8 with a standard deviation of 8.8. Scores on the quantitative portion of the GRE are approximately normally within the mean, mu, blank, and standard deviation, blank.
Okay, so yeah, M stands for the mean. So the mean score was 150.8, right? So you just put that there.
Okay.
And the standard deviation is like the O symbol.
So
That'll
that's
be
8.8.
Mm-hmm.
Okay. Is it really that easy? I know, I was getting. Why is it that easy?
Right, Carrie, that's what you did?
Uh-huh.
Is that what you... Yeah, okay.
Okay.
So for B, do you want to read B?
Yeah. What proportion of the people who take the quantitative portion of the GRE will score above 165?
Okay.
So that's just that you do that same formula that we were doing on the preparation part to find the Z-score.
Z equals X minus M and divided by O.
So it would be, so 165 minus 150.8.
Mm-hmm.
Is that right?
Divided by 8.8.
Yep.
So that 147.86?
You should have gotten 1.6136.
Okay, hold on, let me try that again. 165 minus 150.8. Divide that by 8.8.
Mm-hmm.
Okay. And then do you have the normal probability applet up?
I couldn't find that. I looked, so I even watched the video and tried to like figure it out based on how they explained it to me, but I couldn't find it. So where do I find that app?
Just go to the textbook, you know, where it tells you at the beginning to read.
Yeah.
In the lesson 5. Yeah, it's in there.
Yeah, go there and then go scroll down to what was it? It's down here. Yeah, you'll see a link for it. And you just click on that. Yeah, it's on 2.1 Introduction to the Normal Probability Applet.
So it's just, this is the, okay. Oh, okay. That makes sense. I was looking, like I saw this, but for some reason I was thinking that this was just an example in the textbook. I didn't, this was the actual app. So, that makes so much more sense now, because I honestly, like, I spent like 10 minutes just trying to find the normal probability app that wasn't inside of the textbook, because I thought the one in the textbook wasn't it.
Oh, man.
So that's nice. Okay, so I've got it now.
So then you'll plug into the z-score. You'll plug that 1.6136 into that.
See the bottom?
6.136. Thank you both for being so patient.
Oh.
Okay, 1.6136, and then, and that's the z-score. Is that both z-scores or the first z-score?
Yeah, it'll automatically enter it as a negative and a positive, because it has to be the same on both sides. One's negative and one's positive.
Yep.
Okay.
And then if you look up in the area, that'll give you it should say 0.053 something.
I have 0.10565.
That's what I got the first time I did it. I got 0.0534, but now I got 1067 as well.
Okay, so you guys.
Wait, that's so weird. How did I
got the same answer as you though.
Wait. Okay, so I think. Okay.
So
this is.
You guys.
Oh, sorry. Okay, so the trick is, what proportion of the people will score above 165?
That's what it is. Yeah.
So you have to only have that one the little right-hand corner is the only thing that should be shaded, because that's telling you how many people above that, and that you get is 0.0533.
That's right. Okay, so we got it. Yeah, that's what I got the first time.
So, okay, so where are you finding? I'm sorry. Where are you finding that?
Activist, just click the blue part.
Yeah, just click on the blue part and it turns it white.
Wow! Hey. Okay, I'm sorry.
No, stop apologizing.
Okay, so it's 0.0533.
33. Mm-hmm.
4. 0.05.
Okay, if a student's score is the 10th percentile, what would their corresponding z-score be?
So this one you go up to that area and you change that to 0.1. And you just enter in 0.10.
Mm-hmm. And then the z-score is 1.28.
It's negative 1.282 because that's the 10th percentile, so that's the bottom 10%. So it would be the negative.
Oh. Yeah, that makes sense. Because it's the 10%. Okay, negative 1.
Is Jacob still not here? Huh?
He brought the backpack and put it downstairs for you.
Okay, what is the quantitative GRE score for a student who scores in the 10th percentile? So
and this one was a pain in the rear, but it's
C.
yeah. So you have to do your, so you take that 10th percentile,
Okay.
and you have to solve for, it's on, so if you look in the textbook under 2.4, calculating percentiles using a normal distribution,
Mm-hmm.
So it says, how do we find the batting average that corresponds to the 90th percentile? So that's basically the same question. What is the quantitative GRE score for the 10th percentile?
Mm-hmm.
So do you see that big equation down there? So that's what you had to do. You had to
Okay,
solve for x, that little x-y thing.
Wait, I'm solving for x, or am I solving for z?
No, you already have z. It's negative 1.2816.
Oh, gotcha.
Then you put x. Yeah, x equals m plus z, and then multiply by O.
Okay. Alrighty, so we're gonna take so it's negative 1.28
Yeah, negative 1.282
and
equals, and the x minus 150.8, because that's the mean, divided by 8.8. And so the first thing you do would be to multiply both sides by 8.8.
so 1.28 divided by 8.8.
Negative 1.282 times 8.8, because you're trying to get rid of the 8.8. Like, you're just doing like a regular algebra, like solving for x. So you would times both sides by 8.8, so that gives you negative 11.2816, I think it is. That's what I have written here anyway.
Okay.
And then you would add 150.8 to that, because it's subtracted on that side, so you need to add it.
You need to add back in on the other side.
And so then you end up with 139.52. So that would be the quantitative.
You can round that, right?
Oh yeah, probably 140, right?
Yeah.
What does it have on the?
I did
What's
mine.
the answer on the key?
They rounded to 140.
They round up to, okay.
Yeah.
Oh.
Okay.
What?
Okay.
Are you getting it?
Yes.
Okay.
So the total for that one is going to be 140.
Yes.
If we round it.
Mm-hmm.
Okay. Wow. That's the kind of math I haven't done in 5 years. Okay. 140.
Okay, so 7.
7. Okay, so I just have a question, and this is a basic algebra question, but like I just haven't done math in a long time. So when you're doing, when you're solving for x in an equation, you know what it equals. So basically, you're solving a mystery. And I just want to make sure I understand this correctly. So to get rid of the fraction, the reason that you multiply, like say in the textbook, the example was the 0.034, or in our case 8.8. You're multiplying on each side.
Yeah. You always have to do the same thing to both sides, so it's equal.
Okay, and then once you've multiplied it, then why? So okay, I really should understand this. I'm so sorry, but it's just me learning. Okay, so you have on each side of the fraction. Why did they like? Never mind. I'll just ask the tutor tomorrow. It's cool. Let's keep moving forward. Okay. I'll just practice this and get better at it. And tomorrow I'll understand it better. So let's move on to number 7.
Okay.
So the mean speed of hydrogen at room
The
temperature
mean
is...
speed of hydrogen at room temperature.
Sorry. Go ahead.
Jace?
Hey guys. Sorry.
What? Who's gonna read it?
Are you all ready to go to school? Well, get ready.
I don't know.
Yeah, I'm sure the bell rang.
Do you want me to read it, Aaron?
Yeah, sorry, can you not hear me?
No.
Is Anya still there? Anya, are you there?
Yeah, I'm still here.
Oh, okay. Okay, sorry, I can read it.
Okay.
The mean speed of hydrogen at room temperature is 1,800 ms with a standard deviation of 600 ms. Okay. At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of blank meters per second and a standard deviation of blank. So that would be the 1800 and 600.
Mm-hmm.
What is the probability that a randomly selected particle has a speed over 2500? So then to find that, we do the z equals x minus m over
Yeah.
the standard deviation. Okay.
Uh-huh.
So that's going to be,
So you come up with 1.167, right?
Yeah. And then just plug that in and find the area or the percentile.
so then you pull up your,
So yeah, I got 0.1317.
so you're not solving for it, correct?
What, 0.121, you got
Yeah.
what?
So you have
I got 0.1216.
for 2500.
Huh.
Okay, let me try and see if I can plug it in. So it's 2500 minus 1800 divided by 600.
Yeah.
Yeah, I got 1.167.
Mm-hmm. And then when you plug that in, then do you get 0.1216?
Let me go back.
And if you only have that one right-hand triangle shaded?
So you got 1.167. What is the probability? Okay, and so we're trying to find the probability that a randomly has less than 2500. Okay, so to find that,
No, more than
Okay.
2,500. More than
I
2,500.
did again, and then I got 0.126. I don't know why I wrote 7. Maybe I was looking at the 6, 7, and
Okay.
yeah, I got 0.1216.
yeah, that's what I
Okay.
got as well.
Okay.
So,
So then if you want to do the less than 2,500, then you would unshade the right and do everything else underneath it. And it would be 0.878.
hey, I got it. Okay, yep. 8784. Okay.
So then we do the same thing less than 1,500. So we would do 1,500 minus 1,800 divided by 600.
So, makes sense.
So what did you get?
I got negative 0.5.
That's what I got as
And-
well.
That would be 0.3085.
That's what I have.
Is that what you got, Anya?
No. Hold on. Let me look at it. I think I'm in the right number. Less than 25. Let's see. What is the probability that randomly selected particle has a speed that is less than 50?
So you'd only have the left-hand part shaded, right?
Wait,
To
I mean,
find less than.
we're in D, right?
Mm-hmm.
Oh, okay. Hold on. I got negative 0.5. I was looking at the wrong number down. Okay. And the area is 0.3085, right?
Mm-hmm.
Okay. Sorry, I was
Yeah.
sorry, I was looking at Steve, the one we just did, and that was okay. So on E, that's where I kind of get stuck. This is like
Yeah.
the difficult one.
Because how would you have? You can't do two separate z-scores to get the middle ground in the middle. Let's see on the.
I remember reading in
Let me
textbook.
look on the key what that problem looks like.
Oh, the question. So in the textbook, when it gives example of the heights of the people from Ghana, or the like the problem 2.3.1,
Mm-hmm.
I feel like that's the equation we could use. I think that's it, right? But how did they
Yes.
get from z-score 1.22, which is 0.8888? What does that mean? Like, how did they get that?
Let's see. What is the probability that a randomly selected young Ghanaian woman will be between 155 centimeters and 165 centimeters tall? Recall that for the height of young Ghanaian women, the population mean is 159 centimeters, and the population standard deviation is 4.9. We want to find the probability that a randomly selected woman's height is between 155 and 165. So it looks like you find the z-score for each one of those heights. So
Yeah.
it would be, so you would find the z-score for, well, so we've already found the z-scores for each of those. So we've
Yeah.
already done that.
But how do you
So then what do we do next?
But below that, how do you convert it to like what's C? Now we answer the questions by finding the area under the normal density curve to the left of z-score that equals 1.22, which is 0.8888. How do you find that? Like,
Okay, so we find the area under the normal z-score to the left of z. Okay, so let's try that. Let's enter in the positive one, the bigger one, everything to the left of that. We'll get that. So let's go back up to the applet thing.
okay.
So that's 0.8784, right?
Yep, 0.8783. That's what I thought it's 84.
Wait, how come I'm missing the applet? I scrolled by. Oh, there we go. There we go. Okay, so the z-score 1.167.
Oh yeah, it's greater.
Sure. And then it would be everything below that, so it would be 0.8784. Yeah. So we have 0.8784.
Oh
and
no.
Then,
My applet just closed on me for no reason. Okay, let me go find it.
and then also the area under the normal density curve to the left of z equals negative 82. Okay, so let's, or not negative, but so it would be negative 0.5.
One point.
And that would be 0.3085. That's what we got before.
Wait, what did? Sorry, sorry. My applet closed on me. So for the z-score, you plug the 1.167.
Yeah, and you do everything to the left of that. You find the z-score when you plug that in, everything to the left of that, and that's 0.8784.
Okay, that's what I got.
And then everything to the left of negative 0.5 is 0.3085. And then it says you subtract the larger value the smaller from the larger. So we would subtract 0.8. We would say 0.8784 minus 0.3085. So we get 0.5699. So let's see if we're right. .5698. How could I be off by 1,000th?
I don't know. That's what I'm off by too.
I think this one, yeah, this one's the one that he said we will need extra help on.
Okay, so that for some reason they got 0.8783 instead of 0.8784 for the.
It may have been a rounding difference.
That might be it, but that.
But that's what the
That one-
applet came up with, right? Is the 0.8784?
One,
Yeah.
Yeah.
It is.
667.
Mhm.
Yeah. Okay, that's really strange. Maybe he did it wrong. I don't know.
Yeah, it definitely says 8784, and in the problem down here it says 8783.
I know.
In the key, I mean.
Weird.
Should we?
Get her? Not him?
Maybe Daddy will help you call her.
Okay.
You need to go to bed right now, sister. You have school in the morning.
Daddy?
Okay, well, I don't know. I mean, there's nothing else to. It has to be an error.
Yeah. It has to, because the system wouldn't be wrong. It's so weird.
We can just email him, I guess. If we get something wrong. Anyway.
Yeah.
Okay.
We can shoot him an email and say, hey, this makes sense. Okay.
Okay.
So.
Is the 75th percentile. So if we just put 0.75 in the applet, right?
Wait, where are you still on E? Are you on E
No,
right now?
I moved on to F. Sorry, we
Okay.
already were.
Alright. I just want to make sure. I thought we had, but then I didn't know. So.
Yeah, so I think we would put 0.75 at the top of the probability thing to find out the third quartile, right? Because that's the 75th percentile.
Mhm.
So then we get 0.674.
Yep.
Okay.
Is that right?
I think. Let's look on the key. I'm gonna be really bugged if it's like 1,000th off. It says 0.67449.
Okay, it doesn't give us that, but my computer just gives me 0.674.
Yeah.
Hopefully-
They must not be using the applet. It doesn't make any sense.
No.
But theirs says 0.674 in the illustration. So that
Wait.
doesn't make any sense. But then they have this 67449 where they've added all these numbers. So anyway.
Huh.
So then, so that's the z-score. And now we need to find the actual number, right? So the quantitative number at the 75th percentile. So we have to do another one of those equations.
Okay. So, sorry, can you tell me for F, to get the third quartile, you put in, what did you put into the z-score box? Did you do the 5.699?
Area.
No, on the area I put 0.75 because that's the percentile.
Oh, okay. And
Okay.
then
So
the answer to that was 0.674.
that was the z-score. So now we need to figure out how to get the actual third quartile number.
Gotcha.
That's what we on the part question 6.
2.4 on in the textbook, right?
Let's see.
I don't think it's that same thing because the equation on the key is totally different from that one. So
Oh. But 2.4, you say, yeah.
okay, so yeah,
Oh.
it explains it in 2.4.
Yeah.
Calculating percentiles. Okay, so we got the z-score. So we know z is 1.282, and then we know that what is that? The mean. Do we know what the mean is? The mean is 600, right?
Yeah, the mean is 600.
No. Deviation.
And the standard deviation is the mean is 1800.
Yeah, the mean is 18.
Oh, and the standard deviation is 600.
And the standard deviation is 600. So it says we need to substitute those into the equation. Oh yeah, it is the same thing, isn't it?
So we just take what was the number we just got?
So 0.674 equals x minus 1800 divided by 600, right?
Yeah. So then you multiply 600 on both sides, right?
0.674 times 600. So that's 404.4 equals x minus 1800. And you add 1800, right?
So
wait. Yeah. So 404.4 plus 1800 equals 2204.4.
Okay, once.
So is that the answer? Yep. Yep.
Okay,
So
2,204?
Yep. 2204.4
Yeah.
meters per second.
Okay.
wait, 22,000 or just 2,000? Okay, got it.
Yeah. 2204.4 meters per second is the 75th percentile. Okay.
Okay.
Okay,
So
now
next is
we need to look at the QQ plots and decide if they are normally distributed or not.
Okay. During your group preparation meeting, you will determine whether the data is normally distributed. So we have QQ plot A and that looks, is that a normal distribution? Because
No,
it's not really,
no,
it doesn't
it's like
usually,
it's like a hook instead of being a diagonal line. It should be a normal QQ plot should just be like a diagonal line.
Gotcha. So this is not normal because it goes crazy at the very end. Got it.
And then B, I don't think B is normal either because it's kind of S-shaped rather than.
And plot B is also not normal, right?
Yeah, I don't think it's normal. C.
That was more normal.
Yeah, C looks more normal because it just has the wiggles on the sides, but it's pretty much, yeah, C is normal.
Yeah, it's all even. It goes up at the same rate.
And D looks normal too, don't you think?
Yeah.
Yeah, that does look normal.
And F looks normal.
E does not look normal. Or is it?
Because E has a distinct, it doesn't wiggle back and forth, it has like a distinct curve to it. So I think
So that would
E
make it normal?
I think it would make it not normal.
Not normal.
Because it, instead of just wiggling on both sides of the line, it has like a curve. Well, let's see.
Yeah.
So let's check the key. D is normal. E is not normal. Yeah. F is normal.
Okay.
So we got them all.
Perfect.
All right. Are we ready to take a quiz?
So
Oof.
let's do it. Yeah.
Hopefully it's not as hard as the homework.
Hi, everybody.
Good night.
Oh, yeah.
Love you. Sorry.
Bye.
So are we starting the quiz?
I think so.
Okay. Yeah, are you guys ready? Are you ready?
Yep, I already opened it.
Yeah, mine's not loading yet. Hang on.
Questions are true. Just to let you know.
Oh, you've got those already? Wow.
Yeah.
Awesome.
Okay. True.
Okay, true. True. Total area under the density curve must equal 1, right?
1, yeah.
Yes.
Under certain circumstances, a density curve can drop below the x-axis.
Understood.
The heck?
It's not allowed to go
I thought it had to stay
below.
above it. I don't know. It's me. Yeah.
Is the quiz is open note, right? Open
Yeah,
note,
it is.
open note. So let's look and see if we can find.
Can drop a. That's false. Okay.
Thank you. That was really good. No.
Yeah, because it can't. It can't. Yeah.
Okay, a normal density curve is a symmetric bell shape. The curve lies. Let's see.
The density curve always lies on or above the horizontal axis.
So it's false.
So it's false.
Where are you going?
A normal density curve is symmetric.
Is that true? Hold on. I want to. Yeah.
It is. It says in the reading. It says a normal density curve is symmetric and bell-shaped.
Yeah.
Okay.
Write it down.
Good night. Love you. Okay.
Okay. Use the following
True.
image to answer questions 6 and 7. 6. Which of the following elements of the figure represents the z-score in this image?
So that's
C,
C.
right?
Mm-hmm.
Let's see. Yeah.
Which of the following elements of the figure represents the probability that the random z will be greater than 1.0?
That would be B, right?
Yeah,
That area right there.
at the top.
Oop, B. Come on.
According to the 68, 95, 99 rule, what proportion of the data from a bell-shaped distribution will be within one standard deviation of the mean? 68.
Mm-hmm.
Okay. I'm almost finished with the quiz. He's making
Suppose
this.
a random... Oh, sorry, what?
Oh no, sorry. I was talking because my husband's making dinner tonight and he's asking.
Mhm. That's cool.
Suppose
Suppose-
random. Oh, sorry. Go ahead.
No, you got it. Go.
Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1?
Give you answer as decimal. Accurate to 3 decimal places.
Okay.
Okay.
What proportion? Random variable z has a standard normal distribution. What proportion of the values from this random variable will be between -1 and 1? So that would be, we would just enter -1 as the z-score, right?
That's what I did.
Yeah.
And then we look at the area. I got 0.6827. Is that what we're looking at?
Yep. So if you just do you just shaded the middle portion?
Yeah.
Yeah.
Because it's between those two. That's what they were asking.
6827.
68.
Point,
Well, it's 3 decimal points. So you
0.6827.
want 0.683.
Oh, yeah, 0.683.
Okay.
So that follows the.
Random variable z has a standard normal distribution. What?
Nothing. I was just saying it follows the 68, 95, 99.7 rule.
Gotcha. Okay.
Okay, so we need to do the same thing with -2 and 2.
Mm-hmm.
Wow. 0.9545. So
So do
9.
0.955.
Man, I wish we could take tests together too. You know, we have.
Except I would feel bad. I don't think the score would accurately reflect how much everyone contributes.
All right, let's see.
Okay, so
-3 and 3 is 9.9973, so 0.997.
that's what I got as well.
7.
Look carefully at the answers to the last 3 questions. What do you observe? The
The
16.
values match the 68, 95, 99.7 rule.
Yep. Okay. Do you want to read the next one, Anya?
Okay. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. Wow. Okay, the population mean protein requirement for adults is 0.66 grams, and the population standard deviation is 0.07. Use this information to answer questions 14 through 17. Okay.
Okay, so what proportion have a protein requirements less than 0.60? So you would do the 0.60 minus 0.66, right? Divided by 0.07.
So the mean.
So you subtract the mean from that, 66, and then you would divide it by 0.07. Is that right?
Yeah, that's. Did you guys get 934.28?
Hold on.
60 minus 0.66 equals.
I think I did that wrong. Hold on.
I got negative 0.857142857.
Okay, sorry, let me look at this. 60 minus 0.66 divided by 0.07. Okay, so on 0.60 minus.
Oh, I got it right that time. I don't know what I did wrong last time. So it's
So what'd you get?
I got 0.857. Is that right?
That's what I got. -8.
Yeah, negative.
Okay, so 3 decimal places. Okay.
So you guys got negative 0.857, and that's the right formula, right?
I think so.
Yeah, I think that is. So when you put this, you put negative 0.857.
I just put negative 0.857, but what do you think?
Maybe 0 would be good in front of it.
Okay.
What proportion of the
Oh,
population?
wait. Are you sure we aren't supposed to?
Yeah, wait a second.
Now we need to enter that z-score into the applet, right?
Yeah.
Comment is more than points. Yeah,
So
let's do that.
what proportion is less than 0.60? So we'd shade everything left of that 0.0 negative.
And that would be
0.0.
1.9 or 0.1957, right? So 0.196.
Wait, let's see.
Okay. Negative 8.57. Okay.
And then it would be everything to the left of that, right? So it would be 0.1957.
1957. Yeah.
So
Is
and
that
then,
right? Is
yeah,
that what we're
that's
supposed
right.
to do?
And then you round that, so it's 0.196, right?
Wait, what? Round back?
Round it
We're
up.
supposed to round up.
So 196.
So 0.196, right?
Mm-hmm.
Oh, that's 3 decimal. Oh my gosh, yes.
Okay. So what is more than that? So then we would just shade everything to the right of
I
it.
think so.
So that'd be 0.8043. So 0.804.
Yep. 804.
Okay. Protein requirement is less than 0.70. So we do the same thing only with 0.7. So 0.70 minus 0.66 divided by 0.07. 0.5714. So 0.571 is the z-score.
Point. So you got 0.571.
Yeah. That's what I got.
Wait. I did it wrong. I did 571 and it like went off the thingy. There's nothing. Okay, so then it would be everything to the, it said more than that, right?
It says, so what's less than that? So.
Oh, it's less than that?
Then, yeah.
So it'd be 0.716?
What?
2.284.
That's what I got. 0.2840.
Okay, so did you put, so you put 0.571 on the z-score,
Yeah.
and then you shaded everything to the left of it?
Yeah.
What did you get?
I got
Are we supposed to do the
0.7.
middle one as well?
Yeah, you have to shade everything to
Oh,
everything
okay.
less than that z-score.
Oh, that's right.
0.716.
Right? Isn't that how you do the less than? Is you shade everything
Yes.
to the left?
Yeah.
Yeah,
Okay.
that's correct. I was just confused.
So it's 0.716?
Yeah. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7.
Oh, dang it.
Okay, here we go.
Okay, so let's go back to that one. Okay. Okay. Why? Okay, let's go back to the equation in the book.
Okay.
So we need to we need both those z-scores for
They are 0.57.
0.60 and 0.70. Did you guys keep it? Keep the z-score for 0.60?
Yeah.
For I didn't do it for 0.60. I still have the one from 0.70.
What's that one?
That one is 0.57.
1.
4.
And the other one's negative 0.857.
Okay.
Wait,
So
negative
then-
0.857?
Yeah. No, negative 0.8857.
Okay.
Okay, so then we need to find the area to the left of each of those z-scores. So of 0.571, we have that. It's 0.716.
Okay, yeah.
And then the negative 857.
Wasn't 0.1.
0.1957.
0.196. Wasn't it?
Let's keep it for, let's just round it at the very end. So it would be 0.7160 and 0.1957. And so we would subtract 0.7160 minus 0.1957, 0.5203. Right?
Wait, you got 0.5203?
Mm-hmm.
Hold on, let me try and calculate that one more time. I might have done it wrong.
So for 13, what did we put down? Just a quick question.
For 13,
Yeah.
0.196.
Okay. But it's the same answer for this 0.60 then. I don't know. Never mind.
Shade to the left of each z-score. Yeah, because those were both less than problems, so
Okay.
they would be to the left. The other one was like different because one of them was.
Okay.
So when you subtract 0.1957 from 0.7160, you get 0.5203.
I'm really confused how to do this one.
Well, it explains hint in the hint. Remember that to find the area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area.
Okay, yeah.
Make sure your answer is positive.
And what did you get?
Okay,
0.5203.
0.5.
you got 3.
Mm-hmm.
So wait, after you do, are you on question 16 still? Is that what you're talking about?
Mm-hmm. So we took
Okay, so you have the
0.7160.
0.1760, and you subtract
No,
point-
0.7160. 0.7160 minus
0.7160 minus 0.1957.
7. 0.5203. Is that not what your calculators are saying?
Yeah, that's what that is what I came up with. I just did it wrong last time.
Hold on.
Wait, so you take the after doing the getting rid of the fraction and adding everything together, then you take the end result, which was 0.716 for 0.60. So 0.716. Oh, this one. So 0.7160 minus the result of 0.70, which was 0.1957. And you come out with 0.5203.
Okay. I'm gonna.
Okay, so then is that the actual answer, or do we need to plug that into the graph thing?
No, that's the actual answer.
Okay. So how do you know, I know this is kind of an obvious question, or it should be, but how do you know when you need to plug it into the applet and when to just keep the answer the same?
Well, because you've already plugged those two things into the applet and you're subtracting one from the other.
That's how he got it. Those
That's
numbers.
how
Makes sense. Okay. That makes sense. Okay. So you guys feel good about it? Do you want to submit it?
Yeah.
Okay.
I mean, I just want to, can we look at number 7 just one more time?
Yeah, of course. Oh, and let's make sure with number 16, we need to make sure to round that so we don't have 4 decimal points because we need to have that.
Yeah, just 0.520 is the answer.
Okay.
Okay, so you want to go back to number 7?
I just want to double check 7 because so which of the following elements of the figure represents the probability that the random variable z is greater than 1? So that would definitely be B. Yeah, okay. I just had to make sure.
I think so.
Do we submit it?
Submit? What?
Should we do it? Are we ready?
Yep.
Let's do it.
Okay, 1, 2, 3, go.
Ah.
Yay! 100%.
Wait, 100%?
Yep.
I got my 16 wrong.
What?
It was point
Wait, what did you put?
0.
0.520?
0.250.
No, it's 0.520.
Oh my gosh, I have it. I'm here and I've
Sorry. Oh, dang
no,
it.
my paper had dang it.
Oh, I'm sorry. That stinks.
I know, it's okay. Maybe I'll just email a teacher and be like, oh my gosh, I know I put this number, but
Well, we all worked together as a group, so I would just tell him we all had the same answer, but somehow you flip-flopped the numbers when you were typing it in. He can see that we all have the same answer.
Oh yeah.
I've heard he's pretty reasonable and flexible with things like that.
Yeah, okay. I'll just email him and be like, oh my gosh, that was my dyslexia, I'm gonna say. Okay, well, that was hard.
We did it, though. We conquered.
I know.
Yay!
Well, thank you.
Thanks,
Yeah,
you
thank you
guys.
so much.
Good luck with all the rest of the homework this week.
Oh yeah.
Thank you.
Well,
Good night.
we meet Monday.
Oh, yeah, we got to decide when to meet again.
Monday around 9:30 after family home meeting.
Yeah, let's do it. Sounds good.
Yeah, 9:30 works for me.
9:30. Okay.
Is that too late? I'm sorry, because it's 8:30 here, so.
Yeah.
Okay.
Yeah, let's do that.
All right. Thanks. See you then.
Hey,
Good night. Bye.
bye.